Alright, let's go. Number 10. But before I tell you about the 10 cosmic events that could end life on Earth, I want you to understand something that we almost never think about. We feel safe. We walk around on this planet, going about our lives, and we treat the Earth as a stable, permanent, protected place. And in our daily experience, it is. The ground does not move. The sky does not fall. The sun rises every morning, exactly as it has for billions of years. But that sense of safety is an illusion, a comfortable, necessary illusion, but an illusion nonetheless, because the truth is that our planet is a small, fragile world, floating in a vast and violent universe, protected by nothing but distance and luck. And scattered across the cosmos are events, real, documented, physically possible events, any one of which could end life on Earth. Some of them would give us years of warning, some would give us minutes. And some, the most terrifying of all, would arrive with no warning at all. One moment, everything would be normal. The next, it would be over. This is a list of 10 of them. 10 cosmic events that could, without exaggeration, end life on this planet. Everyone is grounded in real physics. Everyone has either happened before, somewhere in the universe, or is considered a genuine possibility by professional astronomers. And everyone is a reminder that the safety we feel is not guaranteed. It is borrowed, and the universe can call in that debt at any time. By the time we reach number 1, you will understand why some astronomers, the ones who study these threats professionally, have a specific kind of quiet that comes over them when the subject turns to what is actually out there. Because once you understand how exposed we really are, you cannot fully ununderstand it. So let us begin. Number 10. Stapri Epe Ikand. A Nearby Supernova. When a massive star reaches the end of its life, it does not simply fade away, it explodes. In an event called a supernova, the star collapses and then detonates with a violence that is almost impossible to comprehend. For a few weeks, a single supernova can outshine an entire galaxy of hundreds of billions of stars. It releases more energy in that brief moment than our sun will produce over its entire 10 billion year lifetime. Supernovae are, without question, some of the most powerful events in the universe, and they happen regularly. Somewhere in the observable universe, a star explodes as a supernova roughly every second. Most of them are unimaginably far away, harmless to us, visible only as faint points of light in our telescopes. But not all stars are far away. If a supernova were to occur close enough to Earth, the consequences would be catastrophic. The explosion would flood our planet with intense radiation. Gamma rays, X-rays, and ultraviolet light would pour into our atmosphere. And the first casualty would be our ozone layer, the thin, fragile shield that protects all life on Earth from the sun's harmful ultraviolet radiation. If a supernova exploded within about 30 light-years of Earth, the radiation would be intense enough to severely damage or destroy the ozone layer. And without the ozone layer, the sun's ultraviolet radiation would reach the surface unfiltered, sterilizing the land, killing the microscopic plankton that form the base of the ocean food chain, and unraveling the entire web of life from the bottom up. Astronomers have found evidence that this has happened before. Radioactive atoms trapped in seafloor sediments reveal that a supernova exploded roughly 300 light-years from Earth about 2.5 million years ago. That one was far enough away to spare us the worst, but it left its fingerprint in the geological record, a permanent reminder that these explosions happen in our neighborhood, and that the distance between survival and catastrophe is simply a matter of how close the next one is. The good news is that we know of no supernova candidate close enough to seriously threaten us in the immediate future. The bad news is that our surveys are incomplete. There may be stars hidden in the dust, masking their true nature, that are closer to the end of their lives than we realize. And if one of them is close enough, we may not know until it is already too late. Number 9. A gamma-ray burst pointed directly at us. If a supernova is one of the most powerful events in the universe, a gamma-ray burst is something even more extreme. It is quite possibly the most violent phenomenon in all of existence, short of the Big Bang itself. A gamma-ray burst occurs when certain kinds of massive stars collapse, or when two neutron stars merge. But unlike a supernova, which releases its energy in all directions, a gamma-ray burst focuses its energy into two narrow beams, blasting out from the poles of the dying star at nearly the speed of light. These beams are so concentrated, so intense, that a gamma-ray burst can be detected from across the entire observable universe, from billions of light-years away. And here is what makes them so terrifying. Because the energy is focused into a narrow beam, a gamma-ray burst does not need to be nearby to be lethal. A gamma-ray burst aimed directly at Earth could severely damage our ozone layer from as far away as 10,000 light-years. That is a distance covering a huge fraction of our entire galaxy. If one of these beams were pointed at Earth, and if it originated within that range, the effects would be devastating. In seconds, the burst would strip away a significant portion of our ozone layer. It would trigger chemical reactions in the atmosphere that would create a brown smog of nitrogen dioxide, dimming the sun. And it would expose the surface to a level of ultraviolet radiation that life is simply not equipped to handle. Some astronomers believe that a gamma-ray burst may have already caused a mass extinction on Earth. The first great extinction event, roughly 440 million years ago, wiped out about 60% of all marine creatures. And one leading hypothesis for what caused it is a gamma-ray burst, striking the Earth, destroying the ozone layer, and unraveling the ecosystems of the ancient oceans. The most disturbing part of a gamma-ray burst is that we would never see it coming. The burst travels at the speed of light, which means the radiation arrives at exactly the same moment as the light that would warn us of it. There is no advance notice, no time to prepare. If a gamma-ray burst is pointed at Earth and close enough to harm us, the first sign we would have is the event itself, already happening, already too late. Number 8. A rogue black hole drifting through the solar system. We usually think of black holes as distant objects, anchored at the centers of galaxies, far from anything that could affect us. But not all black holes are anchored. Some of them wander. When galaxies collide, or when black holes are ejected from their birthplaces by gravitational interactions, they can be flung out into space, drifting freely through the galaxy. These are called rogue black holes, and astronomers estimate that there could be millions of them wandering through the Milky Way alone. A rogue black hole is one of the most terrifying possible threats for one specific reason. It is completely invisible. A black hole emits no light. In the empty darkness between the stars, a wandering black hole would give off no signal, no warning, no glow. It would be a region of pure gravity, moving silently through space, utterly undetectable, unless it happened to pass in front of a distant star and bend its light, or unless something fell into it and flared briefly before vanishing. If a rogue black hole were to drift into our solar system, the consequences would be catastrophic long before it ever reached the Earth. Its gravity would disrupt the orbits of the planets. It would fling comets and asteroids out of their stable paths, scattering them chaotically through the inner solar system, some of them potentially toward Earth. It would perturb our own orbit around the sun, potentially pushing us closer to the sun, where we would burn, or farther away, where we would freeze. And if it came close enough, its tidal forces would begin to tear at the Earth itself, stretching and stressing the planet in ways that would trigger catastrophic geological upheaval. Earthquakes, volcanic eruptions, the unraveling of the very structure of our world. We have no way to detect a rogue black hole until it is relatively close. And by the time we detected the gravitational disruptions it caused, it would already be inside our solar system, already altering the orbits of the planets, already beyond anything we could do to stop it. It would be a silent, invisible executioner, and we would not know it had arrived until the sky itself began to change. Number 7. A solar superflare from our own sun. We have talked about distant threats, exploding stars, gamma-ray bursts, wandering black holes, but one of the most likely cosmic threats to our civilization comes from the one star we depend on most, our own sun. The sun is not the calm, steady, unchanging object it appears to be. It is a churning ball of plasma, racked by powerful magnetic fields, that regularly releases enormous bursts of energy called solar flares and coronal mass ejections. Most of these are harmless to us, deflected by the Earth's magnetic field, or simply missing us entirely. But occasionally, the sun produces something far more powerful, a superflare. In 1859, the Earth was struck by the most powerful solar storm in recorded history. It is called the Carrington event. When it hit, it caused telegraph systems across Europe and North America to fail. Telegraph operators reported sparks leaping from their equipment. Some telegraph lines caught fire. Auroras, the northern lights, were seen as far south as the Caribbean, so bright that people could read newspapers by their glow in the middle of the night. In 1859, the damage was limited because our technology was limited. We had telegraphs and little else that depended on electricity. But today, our entire civilization runs on electrical and electronic systems, power grids, satellites, the internet, communications, banking, water treatment, food distribution. All of it depends on a fragile, interconnected web of electrical infrastructure. If a Carrington-level event, or something larger, were to strike the Earth today, the consequences could be catastrophic. The surge of energy could overload and destroy the transformers that power our electrical grids. And here's the terrifying part. These massive transformers are not easy to replace. Many are custom-built, take months or years to manufacture, and there are not enough spares. A severe solar superflare could knock out power grids across entire continents and leave them down not for hours or days, but for months or even years. Imagine a world without electricity for a year. No refrigeration, no water pumping, no functioning hospitals, no communications, no modern food distribution, the collapse of the systems that sustain billions of people. A solar superflare would not end all life on Earth directly, but it could end our civilization as we know it, plunging us back into a pre-industrial existence that our current population is simply not equipped to survive. And the Sun has produced superflares before. Evidence in ancient tree rings and ice cores reveals that the Sun has, on rare occasions, released bursts of energy many times more powerful than the Carrington event. It will do so again. The only question is when, and whether we happen to be in the line of fire when it does. Number 6. An asteroid or comet impact we do not see in time. This is the threat that most people have heard of, thanks to the dinosaurs. 66 million years ago, an asteroid roughly 10 kilometers across struck the Earth near what is now the Yucatan Peninsula in Mexico. The impact released energy equivalent to billions of nuclear bombs. It threw enough dust and debris into the atmosphere to block out the sun for years. It triggered global wildfires, tsunamis, and a collapse of the food chain, and it ended the reign of the dinosaurs, wiping out roughly 75% of all species on Earth. That was not a unique event. The Earth has been struck by large objects many times throughout its history, and it will be struck again. The solar system is full of asteroids and comets, and their orbits are not perfectly stable. Over time, gravitational interactions can send them on new paths, some of which intersect with the orbit of the Earth. We have made great progress in detecting near-Earth objects. We have cataloged most of the largest asteroids, the true civilization enders, and none of the ones we know about are on a collision course in the near future. But our surveys are not complete. Smaller asteroids, still large enough to destroy a city or trigger regional devastation, are much harder to detect, and many remain uncatalogued. And comets, which come from the distant outer solar system, can appear with very little warning, sometimes only months before they reach the inner solar system. A large comet on a collision course with Earth might give us only a few months of notice, and with current technology, a few months is almost certainly not enough time to do anything about it. The dinosaurs did not see it coming. They had no telescopes, no warning, no chance. We have telescopes. But whether we would have enough warning and enough capability to respond depends entirely on the specific object, its size, its speed, and how late we detect it. And for some objects, the answer is that we would simply watch it come, knowing exactly what was about to happen, and be powerless to prevent it. Number 5. The death of a nearby star flooding us with radiation. We have talked about supernovae as sudden explosions, but the deaths of stars can threaten us in subtler ways as well. As stars age and die, they go through violent phases, shedding their outer layers, releasing bursts of radiation, and transforming into exotic objects like neutron stars and white dwarfs. And some of these processes can release dangerous amounts of energy into the surrounding space. Consider a particular kind of dangerous star called a Wolf-Rayet star. These are massive, hot, luminous stars nearing the end of their lives, blowing off their outer layers in powerful stellar winds. When a Wolf-Rayet star finally collapses, it can produce not just a supernova, but potentially a gamma-ray burst, funneling deadly radiation along its rotational axis. There is a specific Wolf-Rayet star called WR104, located roughly 8,000 light-years from Earth. For a time, astronomers were concerned that its rotational axis might be pointed almost directly at us, raising the possibility that when it dies, it could send a gamma-ray burst in our direction. Further study has suggested the alignment may not be as direct as feared, and the distance offers some protection. But WR104 remains a reminder that there are stars out there in our galaxy that are essentially loaded weapons, and whether they are pointed at us is a question of cosmic geometry that we do not always fully understand. The deaths of nearby stars, whether through supernovae, gamma-ray bursts, or other violent processes, represent an ongoing, low-probability but high-consequence threat. Most of the time, we are safe, protected by distance. But the galaxy is old, and stars are dying all the time. Over long enough timescales, the odds that one of these deaths occurs close enough and pointed in the right direction to harm us slowly climbs from unlikely toward inevitable. Number 4. The sun's own unpredictable long-term behavior. We talked about solar superflares as a sudden threat, but our sun poses a subtler, longer-term threat as well, one rooted in the fact that we do not understand its behavior as completely as we would like. The sun goes through cycles of activity, roughly every 11 years, during which its magnetic field flips and its surface activity rises and falls. We have been observing these cycles in detail for a relatively short time, only a few centuries, and in that time we have already seen anomalies. In the 17th century, the sun went through a period called the Maunder Minimum, during which sunspots almost completely disappeared for about 70 years. This period coincided with a stretch of unusually cold weather in Europe, sometimes called the Little Ice Age. The exact relationship between the sun's behavior and Earth's climate during this period is still debated, but it demonstrates that the sun's activity is not perfectly constant, and that changes in that activity can have real consequences for our planet. The sun has been remarkably stable over the timescales that matter for life, but we have only been watching it closely for a very short time compared to its multi-billion-year lifespan. If the sun were to undergo a significant unexpected change in its behavior, an extended period of increased activity, or a sudden shift in its output, the consequences for Earth's climate and for our technology-dependent civilization could be severe. And because we do not fully understand the deep mechanisms driving the sun's behavior, we cannot completely rule out such changes or predict them far in advance. The star we depend on for all life is in the end a complex and not fully predictable object, and our confidence in its steady behavior is based on a very short window of careful observation. The sun has been our reliable companion for all of human history, but history is a blink of an eye compared to the life of a star. Number 3. A collision with an interstellar object. In recent years, we have discovered that our solar system is not a closed, isolated system. It is regularly visited by objects from interstellar space, fragments of other star systems wandering through the galaxy, occasionally passing through our neighborhood. The first confirmed interstellar visitor, an object called Oumuamua, was detected in 2017. A second, a comet called Borisov, was found in 2019. A third, designated 3I/Atlas, was detected in 2025. These objects passed through our solar system and continued on their way, harmless, but they revealed something important. Interstellar objects are passing through our solar system regularly, and we are only just now developing the ability to detect them. Here's the concerning part. We detected all of these objects only after they were already inside our solar system, or on their way out. Our ability to spot incoming interstellar objects with advance warning is extremely limited. They move fast, they come from unexpected directions, and they are often small and dark, difficult to see until they are close. Most interstellar objects are small, and even if one struck the Earth, it would likely burn up in the atmosphere, or cause only localized damage. But size is a spectrum. A large interstellar object, a rogue fragment of rock or ice, traveling at the tremendous speeds typical of interstellar visitors, could strike the Earth with devastating force. And because these objects come from outside our solar system, moving faster than the asteroids and comets we are used to tracking, the warning time would be minimal. An interstellar object on a collision course with Earth would be one of the hardest threats to see coming, and one of the hardest to do anything about. It would arrive from the depths of interstellar space, from a direction we might not be watching, at a speed that would leave us little time to react, and it would carry the accumulated momentum of a journey that may have lasted millions of years, ending in a single, catastrophic instant on the surface of our world. Number 2. A coronal mass ejection that destroys the modern world. We touched on solar superflares earlier, but there is a specific solar threat that deserves its own place near the top of this list because of how likely it is and how devastating it would be to our specific technology-dependent civilization. The coronal mass ejection. A coronal mass ejection is a massive eruption of plasma and magnetic field from the sun's surface. When one of these eruptions is aimed at Earth, it can slam into our planet's magnetic field, causing a geomagnetic storm. And a powerful enough geomagnetic storm could cripple the technological infrastructure that our entire civilization depends on. Here is what makes this threat so serious. It is not a matter of if, but when. The sun produces coronal mass ejections regularly. Most of them miss us, some of them hit us, and cause minor disruptions, but occasionally the sun produces one large enough and aimed precisely enough to cause catastrophic damage. In 2012, the Sun released a coronal mass ejection powerful enough to cause a Carrington-level disaster. It would have devastated the technological infrastructure of any planet in its path, and it crossed the exact orbit of the Earth. We were spared only because the eruption happened about a week before the Earth reached that point in its orbit. We missed catastrophe by a matter of days. Pure luck. If that ejection had been timed just slightly differently, if the Earth had been in that position when it erupted, we would have been struck by a solar storm, powerful enough to potentially collapse power grids across the planet, and most people would never have known how close we came. A severe coronal mass ejection could knock out the transformers that power our electrical grids, disable satellites, cripple communications, and plunge large portions of the world into a blackout lasting months or years. The economic damage would be measured in trillions. The human cost from the collapse of the systems that sustain modern life could be measured in millions of lives, and it is coming. Not maybe, not possibly. Certainly, the only questions are when and how large, and whether we will have prepared for it or whether it will catch us, as the 2012 event nearly did, completely by surprise. Number 1, the gamma ray burst we will never see coming. We have saved the most terrifying threat for last, and it is terrifying not because it is the most powerful, though it is among the most powerful. It is terrifying because of one specific, horrifying quality that sets it apart from every other threat on this list. We would have absolutely no warning. Every other threat we have discussed offers at least some possibility of detection. A supernova candidate can be studied in advance, an asteroid can be tracked, a coronal mass ejection is detected as it leaves the Sun, giving us hours or days of notice. Even a rogue black hole would announce itself through gravitational disruptions before it reached us, but a gamma-ray burst, aimed directly at Earth, would arrive with no warning whatsoever. And the reason is rooted in the fundamental physics of the universe. A gamma-ray burst travels at the speed of light. The gamma rays themselves, the lethal radiation, move at exactly the same speed as the light that would allow us to see the event happening, which means there is no way for the warning to arrive before the threat. The light that tells us a gamma-ray burst has occurred arrives at precisely the same instant as the radiation that would kill us. They are the same event, arriving together, at the speed of light. So if a gamma-ray burst were pointed at Earth from a dying star somewhere in our galaxy, we would have no way to know. No telescope could warn us. No early detection system could help. The star could have exploded thousands of years ago, the beam of radiation traveling silently across the galaxy toward us all that time, and we would remain completely unaware until the instant it struck. And when it struck, the effects would be immediate and catastrophic. In seconds, the burst would tear apart the ozone layer over an entire hemisphere. It would flood the atmosphere with radiation. It would trigger chemical changes that would darken the sky and poison the air. The side of the Earth facing the burst would be sterilized by radiation, and even the far side would not escape, as the atmospheric damage spread around the globe in the days and weeks that followed. The most disturbing part is the ordinariness of the moment before. There would be no dramatic buildup, no warning lights, no time to say goodbye. You would be going about your day exactly as you are now, in a world that felt safe and stable and permanent. And then, in an instant, without any warning at all, the sky would fill with a light that should not be there, and the slow unraveling of everything would begin. And by the time anyone understood what had happened, it would already be far too late. We do not know of any gamma-ray burst currently pointed at Earth. We have no specific reason to believe one is imminent, but that is precisely the point. We would not know. We cannot know. The nature of the threat is that it is invisible until the moment it arrives. Somewhere in our galaxy, there may be a dying star, its rotational axis aligned with Earth, its final collapse already underway, the beam of radiation already racing toward us across the light years. Or there may not be. We have no way to tell. And we will not know the answer until either it happens or it does not. This is the reality of living on a small planet in a vast and violent universe. We are protected by distance and by luck, and by the simple fact that space is very large and lethal. Events are relatively rare. But rare is not the same as never, and the universe does not care about our sense of safety. It does not know we are here. It follows its own laws, indifferent to the fragile film of life clinging to the surface of one small world. And any one of the events on this list could, at any time, bring that fragile film to an end. And that senior astronomer, the one some of you have asked me about, the one who allegedly said, off the record, that he wished we had never looked. When he said it, he was not talking about the beauty of the cosmos. He was talking about this, about the growing awareness that comes to everyone who studies these threats long enough, of exactly how exposed we are, of how many ways the universe could end us, of how little warning we would have, and of how completely powerless we would be to stop most of it. Once you understand the threats that surround us, you carry that understanding with you. You look up at the night sky, and you no longer see only beauty. You see the loaded weapons, the dying stars, the invisible wanderers, the vast, indifferent machinery of a universe that could, at any moment, and without any warning, bring everything we have ever known to an end. But here's the other side of that knowledge. Every day that the sky does not fall is a gift. Every ordinary morning, every quiet night, every unremarkable day in which nothing cosmic happens is a day that the universe, in its vast indifference, has allowed us to continue. We are here, against staggering odds, in a brief window of safety, on a small blue world, in a universe that could end us, but has not. And that fragile, borrowed, precious safety is exactly why every single day we get is worth everything. If this video changed the way you look at the sky, then you should know there are other threats, other cosmic dangers, that I could not fit into this list. I made a video about those. It is on the screen right now. If this one kept you up, that one will keep you up longer. And if you want to be here for as long as the universe allows, hit subscribe, because we are still here. The sky has not fallen, and there is still so much left to see. Alright, see you in the next one.